Hello, hello. Welcome back to another one of my deck vlogs. And here, as you can see, I've expanded my worm from just a head and brain and heart and body to a couple of segments, just to prototype out what it would look like for a worm to have a working nervous system that connects to multiple parts of a body. I introduced a new type of internal component. What did I call it? I call it a connector or something like that. Yeah, the body part connector. And the idea is that whatever body part that it is inside, when the body part pulses, basically whenever the brain impulses, it passes its signal on to the outer body part, and then the outer body part conveys that signal back to all the components within inside of that body part, all the organs. And since head to segment one, this connector is part of those, it receives that signal. And then from there, it will have a parameter that stores the segment that it is actually connected to, the body part. So when you look at this guy here, you will see that there should be a 2 configuration. And I have that configured to segment 1. So this connects to segment 1, which allows segment 1 to convey its signal to the next component. And from there, since it's a body part, just like this one, it does the exact same thing as it does. It emits a signal to its children, and since that only one is another segment, and that one is pointed to segment 2, as you can see here, segment 2, does the same thing. We repeat, and we repeat until we get to the last one, which doesn't have anything inside of it, and then the signal terminates. The same thing happens with the blood impulse whenever the heart beats. So that's neat. But one thing I wanted to do was to make it to where I could actually visualize what this looks like as it processes through the body, just to make sure that it makes sense. Because what I noticed is that as I was just logging things out and as the beats were echoing out, the log was just getting very jumbly, and I couldn't tell if it was going in the right order, right? So what I ended up doing was digging into how I can modify a material dynamically, which is not a strong suit of mine. So I welcome any comments below to give me an idea of what I could be doing better. But here I have a test material. This material, all it does is it has a couple parameters that I'm going to modify. And shout out to Zach from my office for giving me this idea to start from, because it gave me a really great starting point, because I wasn't sure like multiplying was a thing and why I would want to do that. Soon realized that it does make something really shiny when you multiply it by a certain value. So here you can see you can change the roughness, the base color, the emissive color, and also the emissive amount that gets multiplied and passed into the base test material. Once I instantiated that as a material instance, I just saved this and I moved on to updating each body part to use this new material. So as you can see here, it's all a default material that I created, but when you go into the event graph, you'll see a couple things. But first of all, you'll see that I have set up this get test dynamic mat or material, which is a function I created in a function library because I realized I was going to reuse this a lot across all of these components to get them to flash. And that's the intended idea. So whenever something receives an impulse from either blood or nerve, it will actually get brighter. And I'm using a timeline node to fade them back out. I'm also utilizing that to buffer the time between each signal being sent out. So moving on, as you can see, it takes a dynamic material that I create and pass into this function, the amount of emission that I want to have occur, and then the color that I want to have it be set to when it flashes. I use the set scalar parameter and set vector parameter to be able to affect the emissive amount and emissive colors on this. And that's just for flashing dynamic mag. To make one, I use this, which just takes a target mesh and a default base color. uses those values to create a dynamic material instance, sets those values appropriately, and then ultimately returns dynamic material. But as you can see, I'm using set vector parameter, set material, these things to be able to make that happen. And I'm affecting the base color there. This was one thing I specifically had a hard time remembering, because it's not just like set this or that. It's set a specific type of parameter, and you had to pass in the right name. I found that to be an interesting thing to learn. I don't know why it's a different pattern for materials, but you know, quirks are quirks, and you just figure them out. So once I established these functions, I was able to more efficiently just set up these mesh materials that I wanted to have be affected dynamically at runtime. So what's happening here in the base body, which is this blue block here, is that I'm binding to the input of a 1 on the keyboard, and then I'm using flash test dynamic mat, which is again this library method that I just created to make it easy to just set it to be a brighter value and then to a different color. So you pass those in, you give it a color, and here I'm just going to make it like a slightly lighter blue. The emissive amount just defaults to 25. Oh, actually, it's just 5 here. Either way, it gets brighter. And then I use this timeline node to configure how long it'll take for the animation to fade the flash out. And it looks like this. So all it is, it's a value from, I wonder if I can just make it, from 0 to, well, 1 to 0, I believe. Yeah. So it goes from 1, and then over 3 seconds, it goes to 0. And every time that value changes at a relevant speed, the alpha value gets passed through. So every update, I set the scalar parameter value to the emissive amount times the alpha amount being passed through. So at 0, maybe it's 1 to 0. So it starts at 1, so 1 times 5 in this case equals 5, and that's the value that gets passed through. And as it goes through, it'll be 0.99, 0.98, 0.5, 0.2, and then that just reduces the amount of emissive amount being emitted to 0 once it finishes. And then once it finishes animating the material, I go ahead and I invoke the brain tick. The start brain tick, as I mentioned in my last episode, is that it's a global event used using the events system that I installed as a plugin from out of the box. And what that does is it fires, and anything listening to it will actually fire no matter where it is. So here it's easy to reach out to the brain inside of the body part and say, okay, when this fires, I want this to happen. So when I press 1, this gets fired. I do another flash of the material. I do another timeline. It's the same 1 to 0 value that I have going over 3 seconds. And then when it finishes, I fire the actual brain tick. So when you see something fade out, that's when the pulse gets fired to the next component in the line, right? And then I'm doing the same update sequence for the material so you can see it actually fade out. One thing I'll note is that one quirk that UE has, Unreal Engine has, is that you can't encapsulate this functionality at all. Anything that has a timeline node, it has to be on this upper level blueprint. It can't be in a function to be called later or anything like that. It's just a one weird quirk of Unreal, and you'll see that it's annoying because I'm repeating it multiple times across multiple blueprints, and I wish there was a way to get around that. All the guides I see always recommend this. Even people I've worked with face-to-face or call-to-call, they always recommend using this, but it's just so annoying to encapsulate for situations like I'm running into here. So that complaint aside, I did do it and it does work. Hopefully once I get to the testing portion of this, it does work. So once this finishes, like I mentioned before, brain tick fires, we look at brain tick. All it's doing is invoking on actor a nerve impulse, which is gonna reach out to its parent, which is the body part. So we should see this flash yellow, and then once it fades out, this one should flash green because I have it configured as green in 2 cases. This listens to both nerve and blood impulses, and those events get fired on every child, and then also once it's completed, I run the actual fade out animation after flashing it, because I didn't want to run on every iteration of the loop. So every actor inside of this body part receives a nerve impulse event, and that includes the heart, but not the brain, because the brain's not listening to it. So what's happening here is the same basic thing. I flash the material, I fade it out, and then once it's done, I fire another event to fire a blood impulse, and its parent, the body part, once again, receives that event, and then it gets propagated to its children once again. So that same pattern's at work here, and the only new thing, really, aside from the animations, is this body part connector. Now, body part connector does the same basic thing. I create a dynamic material, I flash it on these impulses, but what it's doing at the end, when it's finished animating, is it's firing that same nerve impulse event on what it's configured to fire it on. So this means that you can use this to actually propagate the event to the next component. And the same with the blood impulse. So, as you can see, I removed all the print logs just to make it a little bit more condensed. And it should just propagate. So what I expect to happen is I press 1, this blue outermost body flashes, and then it'll hop to inside the brain because it's reaching out with a global event into the brain to just kick it off. So lightning will strike, the brain will fire, it'll flash. At the end of its fade, the body part will flash. And then at the end of this, well, actually, it'll almost immediately flash the heart and the connector pin. So these both might flash at the same time. And what will happen at that point is, once this is finished flashing, this should then flash. And then I think, see, 2 things might be happening at the same time. But ultimately, we'll be going down the line of the connectors and seeing things flash down the line. And then from there, I think it'll all just flash on and off, and we'll see the brain and the heart iterating itself. So whichever is flashing at the moment is what's being conveyed most likely. Or it might be the opposite, but I think it'll be a close enough representation to show that this is working. So without further ado, here we go. So here we are. We're in the world. We're going to hit 1. The body flashes. There's the brain. There's the body and the heart, it looks like. Oh, and the connector. And as you can see, it's going back and forth between brain and heart, and the segments are all lighting up. So the heart flashes, that impulse gets passed. The brain flashes, that gets passed. As you can see here, I'm not pressing 1 again, it's just self-sustaining. Now this is obviously pretty flashy, but ultimately the next step here is just to see if I can't use this, build upon this and see what happens if I were to damage a body part or do something like that. So stay tuned, we'll see how far I get next time. Thank you for watching. Have a good night.